Hello student, welcome to my channel Learn Physics. I have already uploaded the theory of work and energy and numerical of work energy. This video will be extremely helpful for you. Now today I will be discussing the exemplar numerical of NCERT of work and energy. Okay, now let's start. Exemplar question number 1. When a body falls freely towards the earth, its total energy. Look at this. When a body falls freely, its energy is kinetic energy and potential energy. Now sum of potential energy plus kinetic energy is the mechanical energy. So what happens to its mechanical energy? Now from conservation of mechanical energy, the mechanical energy of the body remain constant. When a body falls under gravity, it obeys the conservation of mechanical energy. This is known COME, conservation of mechanical energy. So its mechanical energy remains conserved. That is sum of potential energy plus kinetic energy is constant. Okay. Now question number 2. A car is accelerated on a level road. Its velocity becomes 4 times the initial velocity. Now what happens to its potential energy? Look at this potential energy. This is the mgh, where h is the height above the ground. As the car moves on a level road, so its potential energy remains constant. Okay, understood? Next. Now next question. What will be the angle between force and displacement for negative work done? Look at this. Now during negative work done, force is acting opposite to the direction of displacement. Suppose look at this body moves along this direction, force directed along this direction. So angle between force and displacement, this is the 180 degree. Okay, next. Look at this. An iron sphere of mass 10 kg and an aluminum sphere of mass 3.5 kg are falling from a tower. When they are in 10 meters above the ground, look at this. Their acceleration both have g. Velocity v1 equal to v2 equal to 2gh. But potential energy mg is different because g and h are same, but as their mass different, so their potential energy, kinetic energy are different and momentum also different. So they have same acceleration, same velocity. Okay, understood? Next. Look at this. A girl carrying a school bag of mass 3 kg and moves 200 meters on a level road. Now what will be the work done? Look at this. Here mg, m into 10 acting vertically downward and displacement 200 meter on the horizontal surface. So this angle is 90 degree. Therefore work done is 0. Okay, which are not the unit of energy. Look at this. Joule equal to Newton meter is the unit of energy. Kilowatt into hour, that is power into time, is also the unit of energy, but kilowatt is the unit of power. Okay. Question number 7. On what factors work done does not depends? Look at this. Work done depends on force, work done depends on displacement, and work done also depends on angle between force and displacement. And work done does not depends on initial velocity, it depends on change of kinetic energy. Okay. Now next question. The energy possessed by the water in a dam is the potential energy. When this potential energy is falling, it converted into kinetic energy. And in hydroelectric station, this kinetic energy is converted into electrical energy. Okay. A body falls from a height h. Now what types of energy in it after falling the height h by 2? Look at this. From the height h, the body has initially potential energy. Now, during falling, its potential energy partially converted into kinetic energy. So, after falling the height h by 2, the potential energy becomes half. So, rest half is converted into kinetic energy. So, at the height h by 2, the body has both potential energy and kinetic energy, and both are same. Okay, next. Now a rocket of mass m moves with velocity v. So its kinetic energy equal to half mv square. This is the initial kinetic energy. Now what will be the ratio between initial kinetic energy and final kinetic energy if velocity of the rocket be 3 times? Now initial kinetic energy k1 and is to final kinetic energy k2. Look at this. This is the initial kinetic energy. This is the half mv square. And final kinetic energy, this is half m. This is the v1 square. Now v1 is equal to, look at this, 3v. So this is the half mv square is to half m. This is the 3v whole square. Therefore, look at this, half mv square is to 9 into half mv square. Okay, this and this cancel out. Therefore, this is the 1:9. So ratio of initial kinetic energy and final kinetic energy is equal to 1:9. Okay. Avinas can run 8 meters per second against a frictional force of 10 Newton. Kapil can run 3 meters per second against a frictional force of 25 Newton. Which one more powerful? Power equal to force into velocity. Now power of Avinas is the force into velocity. So look at this, P1 is equal to, this is the F1 into V1. Now F1 is 10 Newton and V1 is 8 Newton. So look at this is the 10 into 8. So this is the 80 watt. Okay. Now look at this, the power of Kapil. Look at this, force into velocity. So P2 is equal to, look at this, F2 into V2. Now what is the F2? 25, V2 3. So look at this, this is the 25 into 3, that is the 75 watt. Power of Avinas is 80 watt, power of Kapil is 75 watt. Therefore Avinas is more powerful. Okay. Look at this, a person moves on a level road against the force of friction of 5 Newton. He moves straight 1500 meter to B and around a half circle along this path and again moves 2000 meter. Now look at this, the radius of this circular section is 100 meter. Now what will be the work done? Look at this, work done is the force into displacement. So we have to calculate displacement BC. Look at this, this is the path followed by the boy. Now, so displacement of this path is the radius plus radius is the diameter. Now diameter is the 200 meter. So displacement of the boy is 1500 meter plus 200 meter plus 2000 meter. Okay. So this is the 3700 meter. Now work done is the force into displacement. What is the force? Force is the 5 Newton and displacement is the 3700 meter. So look at this, this is the joule. Therefore this is the 18500 joule is the work done against the friction by the force. Okay. If the momentum of a body be 0, the body will have mechanical energy. Yes, we know mechanical energy equal to potential energy plus kinetic energy. When momentum of a body is 0, that is its velocity 0. Velocity 0 means kinetic energy 0. A body has potential energy when momentum or velocity of a body is 0. Okay, so body can have mechanical energy when momentum is 0. If mechanical energy is 0, body have momentum? No. Mechanical energy 0 means both potential energy and kinetic energy 0. As kinetic energy 0, so velocity of the body 0. Therefore, momentum is also 0. Okay. Look at this. The power of a pump is 2 kilowatt. How much amount of water raised by the pump per minute to a height of 10 meter? G equal to 10 meter per second square. Now we know power P equal to, this is the work done by time. Now work done is the mgh divided by T. Now look at this, here power is 2 kilowatt hour, that is, this is the 2000 watt. This equal to mass, G is the 10, H is the 10 and this is the 60. Look at this and this cancel out. Look at this and this cancel out. So M is equal to 6 into 200. Therefore, this is the 1200. Therefore, amount of water raised by the pump per minute is 1200 kg. The weight on a person on a planet is half of the weight at Earth. So here mg1 is equal to mg half. So look at this, here g1 is the half g. Now the person jumps 0.4 meter on Earth's surface. What height he can jump on this planet? Look at this, the potential energy of the person remains same. The potential energy mg1h1 is equal to potential energy on the Earth. So look at this, here m and can cancel out. Now g1 is the half g. So look at this is the half g, h1, this is the g, h is equals to 0.4. So look at this, g and g cancel out. Therefore h1 equal to 0.8 meter. Therefore person can jump on the planet is 0.8 meter. Okay. Now question number 17. We have to prove work done is equal to change of kinetic energy. Look at this, an object moves with velocity u on a horizontal road. A force F acting on it produces displacement s on the body when its velocity becomes v. So look at this, from here v square equal to u square plus 2 into acceleration a into s. So here s is equal to v square minus u square by 2a. Now what is the work done by the force? Work done is the force into displacement. So work done is equal to force into displacement. Force is the mass into acceleration and s is the displacement. So here m into a, and this is the v square minus u square divided by 2a. This and this cancel out. So this is the half m v square minus half m u square. Therefore work done is equal to change of kinetic energy. Okay. Next, is it possible that body has an accelerated motion but work done 0? Yes, it is possible. When a body rotates in a circular path, at every point the velocity of the body is directed along this direction, and acceleration is always normal to the direction of velocity, and its acceleration is directed towards the center. So body has acceleration towards the center, but this acceleration is always normal to the direction of motion of the body. So work done is 0, because here it is force acting is called centripetal force, and centripetal force is always normal to the direction of motion. So it is no work force. Okay. A ball falls from height of 10 meter. After striking the ground, its energy is reduced by 40%. That is, energy becomes 60%. How high the ball will ascend? So look at this. Here final potential energy is the 60% of initial potential energy, because the potential energy is reduced by 40%. Therefore look at this, this is the mgh1, this is the 60 by 100, and this is the mass into G, and this is the H is the 10. Okay, so look at this and this cancel out, this and this cancel out, so H1 is the 60 by 100 into 10. Now this cancel out, so this is the 6. So height ascend by the ball is 6 meter. Okay, look at this. An electric heater of power 1200 watt is used for 30 minutes in every day. Find the energy consumed in the month of April. We know energy used in a day is equal to power into time. Now here power is equal to, this is the 1200 and time is equal to, look at this is the half hour. So this is the half. This is the watt into hour. So this is the watt hour. So this is the 600 watt hour. Therefore 600 divided by 1000 kilowatt hour. Okay, so this is the 0.6 kilowatt hour, that is 0.6 units. This energy is consumed in a day. Therefore energy consumed in 30 days, this is the U dash, this is the 0.6 into 30 equal to 18 kilowatt. Okay, understood? Next, look at this. A light body of mass small m and a heavy body of mass capital M have same kinetic energy K. Now we have to calculate the ratio between their momentum, that is P1 is to P2. Which one has larger momentum? Now look at this. If K be the kinetic energy and P be its momentum, then P is equal to root under of 2mk. Therefore momentum P is directly proportional to root over m. Therefore greater the mass of a body, greater its momentum. Therefore look at this, as these two bodies have same kinetic energy, so body having greater mass have greater momentum. Therefore a ratio of their momentum P1 is to P2, this equals to root over 2mk is to root over 2 capital Mk. Now this cancel out, so this is the root over small m is to root over capital M. Okay, understood? Next, look at this. A car of mass 1000 kg moves with 36 km per hour on a level road. If force of friction small f is equal to 100 Newton, find power of the engine. Now look at this. Power of the engine P equal to, this is the force into velocity. Velocity equal to, look at this is the 10 meter per second. So this is the 100 Newton into 10 meter per second. Therefore this is the 1000 watt. Therefore 1 kilowatt is the power of the engine. Now next question. This car collides with another identical stationary car at rest and engine of the car gets stopped. What will be the velocity of the second car V2 after collision? So now if we apply the conservation of linear momentum, we get, look at this is the m1u1 plus m2u2 equal to m1v1 plus m2v2. Look at this, here u1 and u2 given, v1 given, we have to calculate v2. Here m1, this is the 1000 kg, u1, this is the 10. Okay, now this is the also m2 1000 kg into 0 equal to, this is also 1000 kg into v1, this equal to 0 plus this is the 1000 into v2. Okay, now look at this term and this term zeros. So look at this is the 1000 into 10 equal to 1000 into v2. Okay, this and this cancel out, Therefore, V2 equal to 10. Therefore, velocity of the stationary car is equal to 10 meter per second. Okay. Now, exemplar 23. Look at this. A girl of mass 25 kg sits on a trolley. The trolley moves with velocity 4 meter per second. It is brought to rest by a distance of 16 meter. We have to calculate work done on the trolley. The trolley comes to rest from velocity 4 meter per second. Therefore, work done is equal to change of kinetic energy. So look at this, work done on the trolley. This is the half mu square. Here m is equal to 40, u is equal to 4, so this is the square. Therefore, this is the 20 into this is the 16, so this is the 320 joule. Okay, understood? Now, what is the work done by the girl? Look at this. Here, force applied by the girl is 0. So, work done by the girl is 0. Okay, understood? Next, look at this. 4 men lift a load of mass 250 kg through a height of 1 meter. What is the work done to lift the load? Now, we have also calculated work done to hold the load at a height of 1 meter. Third question, why the person get tired in holding the load at a height of h equal to 1 meter? Okay. Now, first of all, work done to lift the load of height h equal to 1 meter. Here, potential energy of this mass increases. Therefore, work done is equal to change of potential energy. Look at this. Here, work done is equal to mgh. Here, m is the 250 kg and g is the 10 meter per second square. So, this is the 10 and h is the 1. So, work done is equal to 2500 joule. Okay. Now, what is the work done to holding the load at a height of 1 meter? Look at this. Here, displacement 0. So, work done in this case, this is the 0 as displacement is 0. Now, why the person get tired in holding the load at this height? Look at this. Person have to apply the gravitational force on the load to hold it. So muscle strain occur. Due to muscle strain they get tired. Okay. Now question number 25. What is power? Power is the rate of doing work. Now differentiate between kilowatt and kilowatt hour. Kilowatt is the unit of power and kilowatt into hour, that is power into time, is the unit of energy. Now next question. The height of jog fall in Karnataka state is 20 meter. 20 ton water falling per minute from this fall. We have to calculate the equivalent power. Look at this. Here power P equal to, this is the mgh divided by T. Now look at this, m by T, that is rate of falling water into G into H. Now look at this here, 20,000 into 10 to the power 3 kg water falling per minute. So look at this, m by T is the 20,000 into 10 to the power 3 divided by 60. G is the 10 and H is the 20. Okay. Therefore, here power is equal to 2 into 10 to the power 3, 10 to the power 3 and 10. So, this is the 10 to the power 7 divided by 3 watt. Okay. So, this is the 20000 by 3 kilowatt. Okay. Therefore, this is the 6.67 into 10 to the power 3 kilowatt is the equivalent power. Okay. Question number 26. What is the relation between power and velocity? Now second question, the power of a person is 100 watt. How many kilogram of load lift at a speed of 1 meter per second? Now look at this, what is the relation between power and velocity? Look at this, power is equal to work done by time. Now power equal to, this is the work done by time, that is force into displacement by time. Now F into S by T. Look at this, S by T is equal to velocity. So look at this, P equal to force into velocity is the relation between power and velocity. Now second question. Now the power of a person is 100 watt. How many kilogram of weight can he lift at a rate of 1 meter per second? G equal to 10 meter per second square. So look at this, here power is equal to work done by time. Now here work done equal to change of potential energy. Look at this, here mg, here h by t, this is the velocity v, therefore mg into v. Therefore look at this, m is the question mark, g is the 10 and this is the 1. And here P is equal to, look at this, 100 watt. So this is the 100 watt. Now this cancel out. Here M equal to 10. So amount of mass lift at a rate of 1 meter per second is 10 kg. Look at this. Here h by t, rate of lift of the mass, is equal to velocity. Okay, understood? Next. Now define watt. Watt is the unit of power. If an engine or an agent doing work 1 joule in 1 second, now we have to express 1 kilowatt into joule per second. Look at this, 1 kilowatt, this equal to 1000 watt, and 1 watt equal to 1 joule per second. So this is the 1000 joule per second. Okay. A car engine of mass 150 kg, exact power 500 watt per kg. Therefore total power P equal to P dash into mass. Look at this, 500 watt per kg. So car exert 500 watt power for 1 kg of the engine. So therefore P equal to, this is the 500 into 150 watt. Okay. Now velocity of the car engine, now velocity equal to 20 meter per second. We have to force acting on the car. Look at this, we know power equal to force into velocity. Therefore force equals to power divided by velocity. This is the power is the 500 into 150 divided by velocity is the 20. This and this cancel out, and this is the 25. Therefore force is equal to 25 into 150 Newton. So this is the 3750 Newton is the force acting on the car. Okay, next. Now NCERT 28. A butterfly of mass 0.1 kg moving upward with velocity of 0.5 meter per second. For its upward motion, here force acting on it is m1g. So here force into velocity. Now second question, a squirrel of mass 250 gram moves up with 0.5 meter per second. We have to calculate power m2 into g into v2. Okay. Now look at this. First of all P1. P1 is equal to mass. This is the 0.1 gram. It should be converted into kg. So this is the 1000. And G is the 10 and velocity is the 0.5. Okay. So look at this. This into this. So this is the 0.5 by 1000 watt. So this is the 5 into 10 to the power minus 4 watt is the power of a butterfly. Okay. Now second, squirrel. The power of squirrel is equal to, this is the m2 into g into v2. So here m2 is equal to 250 gram. It should be converted into kilogram. This is the g and this is the v2. So look at this. This is the 250 gram divided by 1000. So it should be converted into kg. G is the 10 and V2 is the 0.5 meter per second. Look at this, this is the 0.5 meter per second. Look at this, this is the 5 and this cancel out 4. So this is the 5 by 4 watt. Therefore, this is the 1.25 watt. Okay, many thanks for watching this video. The solution of this numerical of exemplar will be extremely helpful for your need, main and advanced. Please like, share and comments on the video and subscribe my channel to learn physics easily. Okay.